Hi guys. Prompted by one of the questions that I got from one of you, I thought I better make a quick screen dump of exactly what I mean by some of these literature search things. So you've already encountered the fact that literature, the nomenclature here is a nightmare because not everyone uses the same notation when talking about the same objects. You already know that some people use BRC and some people use SFO as the catalog identifier to go with the number. So you already know that it's kind of a nightmare. So one of the things that you could do is search on SFO 27 in the abstract, see that I'm putting it in quotes, and see what you come up with. And then try again BRC 27, and you might come up with slightly different things. The other thing you might try is bright rimmed clouds, all in quotes. That would then again, look for things that have those three words together. But, you know, this is not going to necessarily give you a complete search result. So try going to Simbad, and what you want to do is actually search by position within Simbad. You can go search by coordinates in Simbad, and you can put in I have a handy dandy post-it next to my computer with all the coordinates. But 07, 03, 59, minus 11, 23, 09 is the coordinates for BRC 27. And I suggested 10 arc minutes because that's about the radius that we're probably going to be searching. So you submit query, and it's going to go away, talk to France, and come back with the list of identifiers. So it says that there's 113 objects in this region. You could plot the list of objects in any of those coordinates. You know, it'll do it, and it'll give you a clickable map. Mine is actually thinking about it, of course, because I decided to actually click on the link. There we go. So it's going to give you a map that you can actually go and click on things. But I find this kind of easier to absorb. So what this is telling me is there's 113 objects within 10 arc minutes of the position I put in. So the first one is IRAS blah 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 at 11 arc seconds away from where I searched. Simbad thinks it's a cloud, and there are 15 references between 1850 and 2012. Look at the names, even just in the first few. See, there's a whole bunch that are JCMT, CPO 2009, CPO 2009, 2MAS, and LDN 1657B. So before I even get out of the first 10, I already know that there's somebody's catalog by the name of JCMT SF. JCMT is the James Clerk Maxwell Telescope, and I don't yet know what SE and SF stand for. CPO 2009 is almost certainly a paper in 2009 by someone whose the first three authors' first initials are C, P, and O. 2MAS, of course, is a big catalog, and whoever was writing about this paper probably was using the standard nomenclature. LDN 1657B means that, in fact, there is a LINS object here in this region by the name 1657B. So before I've even got out of the first 10, I know that there are some good papers to go look at. And scroll down a little bit further, you can see some more variations in nomenclature. There's an OSP 2002, there's a 2E something, usually that's a all-sky survey kind of thing. That's an X-ray source, so that I don't know how useful that's going to be. TYC is Tycho, it's a Tycho catalog, so it's probably a bright star. There's an SEI 99. Okay, so there's a lot more things to look at here, but let's go look first at the IRAS 07016 source. Now, IRAS, of course, was a satellite from the 80s, and so remember, these are this phone number here is a position. So for the things that have really good positional accuracy, that's 07 hours, 03 minutes, 58.3 seconds, minus 11 degrees, 23 seconds. So 23 minutes, 02 seconds. But for missions that had really coarse resolution, you notice that they haven't given it to the same precision. That's because IRAS can't tell the precision to that kind of detail. So it's probably, you know, a relatively big chunk of sky. So IRAS 07016 minus 1118 is Simbad thinks it's a cloud. Now, Simbad is notoriously inaccurate and inconsistent with its classifications, so you have to take this with a grain of salt. But, okay, fine, it thinks it's a cloud. Go down a little bit further, it says there are two synonyms, IRAS 07016 and SFO 27, so it thinks that those two things are the same. You can plot in a variety of different Java applets. You go ahead, play with those if you want, but in the context of this example, let me just go down to references, 15 between 1850 and 2012. So go get the references, and then scroll down here. So There's the Morgan 2010 ammonia observations paper. I think if you go back and look at the BRC 27 publication list, you'll find that we looked at that paper in that list. Star Formation History of Canis Major Wide Field X-ray Study, the Gregorio Hatem paper. I know that we looked at this one and it's on the list of things that we need to scavenge data for. There's the Chauhan paper, the 2009 MNRAS paper. That too is a paper we know about in some detail. We're going to have to read it in some detail. This is another Morgan et al. 2009 MNRAS paper. I think that one is also in the list. Another Morgan 2008 scuba survey. That one's also in the list. Bonato et al. Mass Functions and Structure of the Young Open Cluster NGC 6611. Well, I happen to know that NGC 6611 is the Eagle Nebula, which is a rather long way from where we're looking here. So I don't know exactly why they think this paper mentions that. So you'll have to go get the paper and look. It may be that they just had in a passing glance said, oh, this is completely unlike BRC 27. Or it might have something useful. Maybe they buried observations of BRC 27 somewhere in the appendix of that paper, or maybe Sinbad is just wrong. So that one is a good one to go look at in some detail. Valdataro et al. 2005, that is also on the list of papers that we had from before. That one is a radio paper, and I think the notes say something about might be interesting to read but not critical. There's another Morgan 2004 paper. We found that before, Suarez and Bica. We found before this one. Nice intentions but archaic data, so really not a lot of use in reading that paper for us now. There's another Suarez and Bica. It's the same. They were using early release data from 2MASS. And so they did good stuff at the time in 2003 and 2002, but we can't learn much from it now. Ogura, Sugatani, and Pickles, that's a 2002 paper. That one is also on the list, and that's another one that I know is going to be useful. There's another Sugatani 2000. I think this is the one of the discovery, or one of the follow-ups for the discovery papers. This is one of the discovery papers in 1995. Okay, so we found a couple that are worth pursuing, certainly several that are worth comparing to the list of papers that are already retrieved for BRC 27. So we go back, that was just the first identifier. Let's go see what the JCMT source is. It comes up as a some millimeter source. Well, you know, that could be anything. It could be a knot in the cloud, it could be a young star. It only appears in literature once, the JCMT catalog, and there's only one reference. And you go and get it, and there's a scuba catalog from 2008. Submillimeter continuum objects. So could be useful, maybe not. It might be worth checking to see if this is reported as a non-detection or not. So this is the idea. You go through this entire list and you'll find pretty quickly that, oh, JCMT SE, that's probably the same catalog as this one. And it's going to come back and say, oh, look, there's two identifiers, an SE and an SF, and one reference. I'll bet it's that same paper that we were just looking at. Yep, DiFrancesco. So you'll learn, even though it seems really intimidating to go through 113 objects, it's gonna collapse pretty quickly, because now you know that anything else that's named JCMT something something in this list is going to point to the same reference, especially if there's only one reference listed over here. So that's the idea. You go through. Now, some of these things, these nomenclatures are a little bit difficult to tell, again, because this is Sinbad's classification. It's not always clear or consistent, but a lot of these, this means a candidate young star, meaning young star question mark. It's a dark nebula, so emission star, there's all sorts of other nomenclature. So in other words, don't pay attention to this too closely. What you want in the end is the papers that are listed by Sinbad as tying to this. And then they'll give you a link. I guess I didn't demonstrate that. Let's go find CPO 2009. There's one identifier, one reference, which is probably CPO 2009. Yeah, Chauhan, Pandey, Ogura, something like this. Chauhan et al. 2009. So if you click on that, you'll get taken to, admittedly, the French copy. See up here, the French copy of the abstract, and you can go get, a copy from. Oh, it's funny. You can go get it. It's talking to the French copy of the ADS database, and if you go to link on ADS services, you'll get taken to admittedly the French copy of ADS, but there's the archive ePrint link, so you can go get the archive free copy here, or depending, the 2009 is not quite old enough. If it's old enough paper, you can go to the journal and get the PDF. Sometimes if it's really old, it'll give you a GIF as an option because somebody sat and scanned in the article. So you basically have to keep following the trails of breadcrumbs through all of these papers and try to see, is there anything useful we're trying to get out of this? We're looking for things that are point sources not necessarily diffuse things, but point sources, and we're looking for things that are young stars or known galaxies. Encountering known galaxies is also useful because there will be contamination in what we find, and so if someone can conclusively identify it as a galaxy, we need to know that. Hopefully this makes more sense. Let me know if you still have questions.